Welcome, everyone. So here we're going to take a look at parametric equations and their graphs. So let me tell you what parametric equations are first. So we have seen equations involving x and y. We can represent x as a function of y or y as a function of x. Now we're going to represent both x and y as a function of another new variable. Let's call it t. So parametric equations are equation of this form where x is expressed, let's say, as a function of t, and y is also expressed as a function of t. You can really use any variable, but we're going to use t in this video. And you can also give range for t. For example, t can go from a real number to another real number, or t can go from the entire real line. So having this idea, now let's take a look at some example and see how we can feel comfortable with these type of equations. All right, so let's get our hands on these equations. So for the first one, for all of these, we're going to eliminate the parameter. The parameter is t in this problem. For all of these problems, I'm using t. Your parameter could be really any new variable other than x and y. So first, we're going to eliminate the parameter to find a Cartesian equation, meaning equation of the form x and y of this given curve. And then we're going to sketch the curve and showing the direction where the t is increasing, meaning the parameter is increasing. So let's start off with the first problem. So for the first problem, we're going to, so let me show you how to sketch it first. I think it'll be easier for you to sketch, or maybe if you just find the Cartesian equation, it might be better. You can decide that. So I'm going to start off with sketching it. So I see that x is equal to square root of t. Now we know the square root function is very restricted. So we know that just by looking at it, t must be bigger than or equal to 0, right? We cannot plug in negative values for t. So I make a table of values. We'll create a table with column for t and a column for x and also for y. All right, so that's our table. So we're going to start off with t equals 0. That's the first value. And then you can pick anything bigger than 0 as well. We'll pick some convenient values. So x is determined by square root of t. So if t is 0, I plug in 0 here. I get square root of 0. Square root of 0 is 0. And y is defined as 1 minus t. So when I plug in 0 in place of t, I get 1 minus 0, which will give me 1. So that's our first point, 0, 1. Let's go ahead and plug in another value for t. Let's say 1. So when I plug it into this formula, I get square root of 1. So that gives me 1. And then when I plug it into this formula to determine y, I have 1 minus 1. That would be 0. All right, let's plug in another one. I'm going to go with, now since you could go with 2, but you'll have a square root of 2. You have to estimate. So I'm going to pick 4 for t. Because when I plug in 4 in here, I can take its square root. Square root of 4 would be 2, so x is 2. And then when I plug in 4 here for t, I get 1 minus 4. That would be negative 3. You can continue to plug in a few more values and get a few more x and y coordinates. But I think we have a picture. After 2 or 3 points, you most likely have a picture. So here's our xy plane. So I'm going to scale it this way since y values are more negative. And so the first point we're going to plug in is when t is 0, x and y coordinates are 0, 1. Let's suppose 0, 1 is right here. All right, let's label that 1. So this is the point when t was 0. And the next point is this one, 1, 0. So that's going to hit the x-axis. Let's suppose it's right here. Let me call this one 1, 0. This is the point when t is equal to 1. So you can see the direction of our particle. So it's going this way. The next point we're going to plug in is when t is 4, x is 2, y is negative 3. So x is 2, let's suppose it's here. And then y is negative 2. Let's try to estimate that. Perhaps further down here. So I'm just going to curve it. So I see that it looks like this. So let's suppose this is 2, this is negative 3 down here. All right, so that's the next point. This is the point when t is equal to 4. And then the curve will continue to just follow this path, we can just, our curve is going this way. So there you go, that's your parametric curve. Now, if you were to find the Cartesian equations, meaning eliminate the parameter, we're going to solve for t by using either of these equations. Now, for this problem, solving for t is easier in both forms. So I'm going to go ahead and actually use the first equation to solve for t. So I'll go ahead and square both sides. So since x is equal to square root of t, that means if I square both sides, x squared is equal to t. But be mindful that t is bigger than 0, which also implies that x has to be bigger than and equal to 0. All right, so that is our expression for t. Now we're going to substitute this in here. We have our Cartesian equation. So just make it a bit smaller for you. So our Cartesian equation would be y is equal to 1 minus t is x squared. So there you go. This is your Cartesian equation. Here is our next problem. So again, we're going to sketch the curve, and then we're going to find the Cartesian equation of this parametric equations. So now here's where, for this problem, we're given specific range for t. So t is going to go only from 0 to pi. So it's restricted. So let's make a table. So here's our t column, here's our x column, and here's our y column. So t, I'll pick 0, pi over 2, anything between 0 to pi, and then the last point will be pi. Just very specific ones. Now let's plug it in to each equation. So when t equals 0, here I'm going to evaluate cosine of 0. Cosine of 0 is 1, 1 squared is 1. So this is going to be 1. And then here we have, again, cosine of 0, that's 1, 1 plus 1, that will be 2. So the y coordinate is 2. For the next t value, again, we're doing pi over 2, plug it in here, and also plug it in here. So we're going to have cosine of pi over 2, that's 0. When you square it, you get 0. And then again, cosine of 0, cosine of pi over 2 is 0. So this is 0. Y coordinate will simply be 1. And for pi, if you plug it in here, for the x coordinate, cosine of pi is negative 1. When you square it, you'll get positive 1. So we have 1 right here. For the y coordinates, cosine of pi is negative 1. So negative 1 plus 1, that'll cancel out. You'll have 0. All right, so that's how our table looks like. Now here's the sketch. So we're sketching it in the xy plane. So here's x, here's y. So when t equals 0, we have the point 1, 2. So 1, 2, let's suppose 1 is here, 2 is here. So 1, 2 is right up here. This is when t is equal to 0. Then when t is equal to pi over 2, so increasing t value, x is 0, y is 1. So this is the next point. Now x is 0, y is 1, so that's right here. So we're going this way. That's the direction. This is the point when t is pi over 2. And then when t is pi, we have the point 1, 0. So we're going to come back to this point right here. So that's the direction of our curve. So this is when t is equal to pi. So it's just that little curve represents this Cartesian parametric equations. All right, now let's find its Cartesian form. So I'm going to go ahead and solve for t. So now notice that x is equal to cosine squared t, y is equal to 1 plus cosine t. So it looks easier to just solve for cosine t and plug it in here. So I'm going to go ahead and do that. So we know y is equal to, here's how we're going to get our Cartesian form. We know y is equal to 1 plus cosine t. So you just want to solve for cosine t because x is in terms of cosine t. So you have cosine t is going to be y minus 1. And now since this is cosine of t, I can simply take this expression and plug it right here. We square it. So there you go. That's pretty simple. So that means our x is going to be y minus 1 squared because that's what x is. And you could leave it here, but let's expand and see what this is. So if I expand the right-hand side, this is going to give us y squared minus 2y plus 1. So there you have it. Our Cartesian equation is x equals y squared minus 2y plus 1. That is our Cartesian equation. You have equation in terms of x and y. So we are expressing x as a function of y in this problem. All right, so for this problem, this is our last example. We're given x equals 3 cosine t, y equals 3 sine t, and t will go from 0 to pi. All right, again, restricted t value. Now, again, you can sketch the curve, and you'll see how it looks like. So and I'm going to try to do without the table of values. So hopefully you can do that as well. Since we have done 2 with table, now let's do 1 without it. So let's plug in t equals 0 for each of these t's. So when we know cosine of 0, so when t is equal to 0, our point cosine of 0 is 1. So 3 times 1, that would be 3. And then sine of 0 is 0, so we're going to be at 0. So when t is equal to 0, that is the point. Now when t is equal to, so again, pick anything between 0 to pi. I'm going to go ahead use pi over 2. You could pick pi over 4, pi over 6, anything convenient that you can evaluate. So our next point would be, now cosine of pi over 2 is 0. So this is 3 times 0, that would be 0. And sine of pi over 2 for the y-coordinate, it's going to be 1 times 3, that would be 3. And the last point we're going to pick is the endpoint pi. So when t is pi, cosine of pi is -1, so we have -3. For the y-coordinate, we'll get 0. All right, so I think you already know how this looks like, but let me show you. So the first point is right here. Let's say is when t is 0. This is 3, 0. And then when t is pi over 2, so we're increasing t value, we're going to be right up here. That's the next point. This is when t is pi over 2. And so this is the direction of our curve. And then when t is pi, so we're going to go here, our point. So you can see that it looks like just the upper half of the circle. All right, so I'm struggling to draw this. Hopefully you can draw it better. Let's just say this is the circle. I'm sorry, not the best drawing. This is t equals pi. All right, that is the direction of the curve. So it's just the upper half of the circle. All right, so now to get the Cartesian equation, we're going to have to remember an identity from trigonometry. So first, I'm going to do the following. I'm going to solve each of these equations for sine and cosine. So for the first one, I can divide by 3. So you'll have x divided by 3. That would equal to cosine t. And then y divided by 3 will equal to sine t. Now remember that cosine square of t plus sine square of t is equal to 1. So we know that identity from trigonometry. So I'm going to substitute. Now I know cosine t is x over 3. So I'm going to substitute that right here and then square it. So you'll have x over 3 squared. Sine, we know that's going to be right here, y over 3. We're going to square it. So y over 3 square is equal to 1. And just simplify that. So you'll see that what this equation comes out to be. So we got x squared over 9 plus y squared over 9 is equal to 1. Let's multiply both sides by 9. You'll have x squared plus y squared is equal to 9. So there you have it. That's the Cartesian equation. And as you can see it from the picture, we're looking at the upper half of the circle. So this is the equation, but since it's the equation of the entire circle, you want to restrict your function. So we're going to express this in terms of x. So solve for y, because this equation will represent the entire circle. We don't have that. We only have the upper half. So we're going to go ahead and solve. So we have y squared is equal to 9 minus x squared. And then I'm going to go ahead and take the square root. So we have y is equal to plus and minus the square root of 9 minus x squared. So the plus represents the upper half of the circle. Negative is the lower half. So we're going to take the negative one. Sorry, take the positive one. We'll have our Cartesian equation will simply be square root of 9 minus x squared. And there you have it. That will give us the upper half of the circle. And you can put a restriction on x. You can let x go from only -3 to 3. So that will give you that exact picture. All right, I hope this makes sense. I'll see you next time. Take care, everyone.